Please.
Hey. Hey, thanks for the intro, and thanks everybody for coming, because I know there's beer outside. You can bring beer in here, I won't be offended. You can definitely do both, right? You can bring me one. Yeah, I assume everybody is here because you either need to sleep, or you actually have to go implement some NIST cloud security standards. I don't really know why else you'd want to hear about this. But luckily for you, I used to do this stuff every day. I have to stress I'm now here in a personal capacity, but I used to do this stuff every day, and I've still got a bunch of that knowledge, so I thought I'd sort of do this talk to take folks through this, because it can be confusing, and there's a lot of these documents, as we'll see, are like very high level, very academic, so I thought I'd try to bring in some more practical guidance for how you can meet these kind of controls. Saying that, this previously was a two-person talk. It was a bit longer, so I will probably spend most of the time today talking about what the standards are and what they're actually trying to tell you. There'll be some practical examples, but most of that you can probably work out once we understand what it is we're expected to do. So just a bit of jargon. NIST is a US government body, the National Institute of Standards and Technology. So they publish standards on everything from like weights and measures to recently cybersecurity. And the SPs, the special publications, are the main body of documents, of standards that they produce. For example, SP 500-158 talks about the accuracy, integrity, and security in computerized vote tallying. That's from like 1988, about security of punch card vote machines, because it was very relevant then, and it's actually still very relevant now because people are still suing each other over it. So that's the kind of stuff that NIST does, but then there's the SP 800 series, which are all about information security. If you do need to go read one, just very quickly, they have this structure where they're kind of backwards. So you probably want to sort of start at section 3 and 4. Those are the good bits. Sorry, I don't know if you can see this. They're also, it's worth pointing out that they're not a thesis. These documents aren't trying to say anything that hasn't been said before. There's no new ideas. They're meant to sort of round up and summarize what people are currently doing, the best practices. So like the standards across the industry that everybody should and could already be doing. So we'll dive right in. SP 800-53. This recommended security controls for federal information systems, they said. This is kind of the granddaddy, they called it. It was written by a bunch of people at NIST, a bunch of researchers. This is kind of the original one. The original version is quite old, but the reason it's so important is that it is quite practical. The closest equivalent might be the sort of ISO 27001 appendices, which are much more practical than 27001 itself. It does contain a bit of process stuff, but it's not all telling you how to format your documents. And 53 is referenced included by a whole bunch of other standards. So standards in the banking industry, as I say, ISO 27001, some of the more recent European banking standards, they all reference or just straight copy and paste 853, which is why it's important to I guess, to kind of understand what it's getting at. So for example, so a lot of it's about computer security, right? So a lot of it's about network security. There is some more recent stuff on compute security, so about supply chain attacks and that kind of stuff, but obviously, especially going back a bit, everybody was just concerned about being hacked on their network, right? This new internetwork where we plug all our computers together kind of sounds pretty dangerous. So a lot of it's about that. So there's these famous Security Control 8 and Security Control 9, which respectively say that all your communications over the network need to have integrity and confidentiality guarantees, right? Sounds very simple. Basically, it encrypts your shit. But it doesn't quite say that because it's very academic. So there's other ways to get confidentiality, right? You could use HMAC or something. You don't have to do sort of X509 TLS. There's other ways to get integrity as well. So back in the day, that's the kind of very academic sort of treatment they gave of it. It's also worth saying that a lot of these standards have this sort of low, medium, and high bar. So the control is different depending on whether you're going for low, medium, or high compliance. So for this one, for example, because this standard was 2005, Low is like, well, don't bother with encryption. Like, it's fine, I guess. That nobody's really going to attack your computer. It's only really used by, hobbyists. Medium and high, you do have to do something about it. And actually, moderate says, there's more detail to this that I won't bore you with. Moderate says, yes, you've got to do something. And high says yes, and that's, even in 2005, high said yes, and that something has to be encryption. So, practical examples, like what could we do to get this encryption in transit? Well, you might want a service mesh. I used to work for a service mesh company, so that's the example I gave. But seriously, like as I say, this standard, this is the big original standard, and a lot of it is about network security, and actually a service mesh will hit a lot of the controls in 853, a lot of the technical ones. And if you're cloud native, if you're running on Kubernetes, then a service mesh like Istio or Linkerd or Cilium is easy to install and hopefully quite easy to manage, and will tick a lot of those boxes for you. So there's other controls in there as well, right? So for like intramesh, we've already seen that it says, okay, communication between our services needs to be confidential and integral. So strict mutual TLS will do that, not allowing any traffic within the cluster that's not MTLS. That's a mode that you can put Istio into, for example, and then this, just because you wouldn't think I was a real engineer without some code, this is the YAML you would use to do that. But there's other controls that talk about egress control. You can't just let any random service talk to the internet, because what if you've been compromised and somebody's trying to exfil data? Again, a service mesh, if you will give you, so Istio has this thing called registry-only mode. They all have an equivalent, which is basically only allow communication out that I've whitelisted. And then we can do a sort of defense in depth posture, so we can say that we can force all of our egress traffic through another layer of proxies, through what's called an egress gateway. And if we put those on dedicated nodes, then we can use Kubernetes network policy, we can use cloud provider security groups to put controls and say, okay, well, only pods on these dedicated egress nodes are allowed to talk to the internet. So I now have this, even if my mesh security fails, I now have this defense in depth that if a service gets breached and bypasses its local proxy, it actually can't talk out to the internet. And this is just the kind of thing that makes auditors very happy, right? Not least because they might struggle to understand some of the newer tech that you're using. What they will understand is VLANs, firewall rules on an F5, that kind of thing. And ultimately, being secure and complying with 853 are great, and it's a good standard. I think those two things mostly overlap. But what you actually have to do is convince your auditor. So that's unfortunately what we have to optimize for. Now, hopefully all three of those things are aligned, but again, some practical advice, like it is maybe auditor-driven development. But they're getting better, and as I say, the standard is actually pretty good. So yeah, the original 853 came out in 2005. Things have moved on a lot. We're up to revision 5, update 1. We're basically up to version 5.1. It's changed so much, they've changed the name of it, but it is really the same thing, and it's now attributed to the Joint Task Force, which means that like so many people have had pull requests into this thing that they can't name them anymore. But it's got better, it's kept up to date, and importantly, this is the standard that FedRAMP is in, or that FedRAMP references. So for folks who've heard of FedRAMP, if you are supplying to any branch of the US government, so they call them government agencies, but they don't just mean like the 3-letter agencies, they mean any branch of the US federal government, you have to be FedRAMP compliant. And FedRAMP is a subset of controls in the later revisions, revision 4 and revision 5 of 853. FedRAMP, again, actually has these low, moderate, and high levels, which pick the low, moderate, and high controls out of 53. Just another note on that is it's got even more complicated. So not only, remember, we had some controls are in moderate but not in low, there's actually different definitions of them as well. So if you want to go from low to moderate, it isn't just about adding some more controls. You might have to go and reinterpret the ones you've already done. So again, if you're going to have that second expensive conversation with your auditor to try to persuade them that you're now moderate and you were low before, you will need to go back and actually you'll have to look at every control again. just an example of how complicated this gets and how it's okay to ask for help, maybe, from somebody who's done it before. Those, remember the old SC8 and SC9? I need my communication to be private, essentially. They've been rolled up in the later versions into one requirement, and that requirement helpfully says all data in transit, DIT, because they love an acronym, all data in transit between OS processes, right down to that level, between two processes on a Linux machine, must be protected. So what does that mean? There's another random document, ostensibly about vulnerability scanning, but section 4 of that document about vulnerability scanning actually clarifies this a little bit and explicitly and says, any data in transit, blah, 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 security control 8 protection, brackets, usually encryption. Usually. So this is subsection 5 of security control 8, and this talks about a controlled access area. So it defines controlled access area somewhere, which is this idea of a bunch of systems that are close enough together that you control all the access to them. So like one data center is, a high security data center is a controlled access area. So a cloud availability zone is a controlled access area. And within a CAA, the rules change a little bit. This is basically saying, maybe I've screen capped the wrong thing. That's how complicated it is. But so they go and define this controlled access area, and then it gets worse. There is a Word doc, which then goes and clarifies things even more, and finally says, data in transit, if it stays within a controlled access area, for clarity, this controls to all data in access. Right. For each instance of data in transit, cryptography specified in Security Control 8, Section 1, but physical means as specified in Section 5 are acceptable. So if you're within one of these controlled access areas, so if you're within a data center, within an AZ, then you can actually just rely on the fact that you've got that physical barrier and you don't necessarily need encryption, which is why the previous one says usually encryption and why this thing says protected. So you have to go find all of these random documents. There is also a blog, a random blog, the revision 5 approach to security control 8 and protecting data in transit. This one actually is very helpful. This one, okay, this is the screen cap I was looking for. Finally, for data in transit, guaranteed to stay within a single controlled access area, which we've defined to be one physically secure place, like a data center, typically a data center. Physical protection, as in lock the doors, lock the racks, will be sufficient. So you don't technically need encryption. Why are we talking about this? Well, because this is what obviously the auditor is going to check you for. And even if you are using, the problem folks have had is even if you're using a service mesh, if you folks know how a service mesh works, it puts a proxy alongside every workload as a sidecar. So technically you are unencrypted between the application and the sidecar, even though that's in the same pod. So it's in the same network namespace, right? It's going over like a loopback interface. It's definitely within the same building because it has to be on the same node, right? Because they're sharing a kernel, it's one pod. But technically you are unencrypted. If somebody can break into the network, break into the host, break into the pod, then, so some auditors have been saying, well, I need encryption between every OS process. Remember, that's what the original document said. So finally, after clarification, if you know it's going to stay in the same building, you're fine. Do remember, though, that some AWS AZs are more than one building, and you're going to have to go look at the AWS artifacts list to see if your AZ is one building or not. Because you know you're in the same, you know you're going to stay in one building because you know the sidecar is literally on the same physical node. Does your auditor understand that necessarily? What they will understand is, yes, it definitely stays in one building and the door is locked. That gives you an easier time. So helpful practical advice. Anyway, back on track. How am I doing? Oh, I don't actually have long left. All of which is to say, you should read the documents. There is help out there if you need it. There are a lot of consultancies and vendors that will help you in exchange for some money. But there's also like, folks have worked this out, and like the right kind of Googling and possibly the right ChatGPT prompt will help you understand this stuff. But you can't necessarily take all the documents at face value. Just to whip through the rest, there. So we had 800-53 without a letter. If you're talking to an American, they will call that 800-53 naked. In addition to the naked ones, we have the more respectable, the more safe for work 53A. This one basically talks about organizational risk management. So this talks about how you would audit, how they expect you to audit a system that complies with 53. There's 53B, which is much more practical. So this is actually a set of baseline for what the controls might look like. So this is a very sensible, useful doc to go and read. So just covering some of the things in 53B, like some of the controls you have can be fully implemented by a piece of tech, right? By a technical tool. So that what's called the mapping here, the how do I take this requirement in the document and turn it into something I can do, is quite simple. Like we saw that short piece of YAML before. You need encryption in transit everywhere, so you install Istio, you deploy that 4-line YAML, and you've got it. Some of the controls are human-focused and talk about access audits, and some of them do even talk about documentation standards, and then some of them are kind of somewhere in the middle. So there's AC4, which is access control standard, access control requirement number 4, is written in very bureaucratic language, but basically says you need some kind of service-to-service access control. So some kind of firewalling, right, but micro firewalling between all your services. So again, like this is one that we can hit full support with a tech tool. Again, I'm going to talk about Istio Service Mesh. This is the example I pulled out. But using X509 certificates to give us encryption in transit, using MTLS, and then using that strong authentication, we can go and turn on the fine-grained authorization, so the access control, and so that's service to service. And in addition to that, the service mesh will also support control of ingress traffic and control of egress traffic. With all of those things together, which are all supported by this one tool, we can go and fully hit like AC4. Something like AC6, on the other hand, says, well, you should use the principle of least privilege, which is quite vague. So on the one hand, yes, all of your services should have the least privileges. If I'm service A calling service B, I should get a token for this fine-grained authorization. And if I only need to read from service B, then that token should only let me read from service B, right? I shouldn't have a token that lets me write to service B or lets me write to service C. But this also applies to people, to my kubectl access, like what I can touch, what kind of API resources I can touch, what times of the day I'm allowed to interact with the cluster, depending maybe on when I'm on call. And a lot of organizations, yours probably does, will every few months we'll sit down and go through the list of people and just make sure that everybody's only got the access they need, and that we didn't give somebody emergency access during an outage, and then they've still got it. So there'll be these more human, processed-focused approaches to least privilege as well. So this is something that you just need to think about in a slightly different way. So as I say, partial support for this with your service mesh. You go turn on your fine-grained authorization, and you design your authorization policies well. But there's also going to be other aspects to it. I'm pretty much out of time, so I'll skip that, and I'll just say, so there's now some newer standards focused pretty much on cloud native, because that's where a lot of the US computer systems are going. 204 is written by a really good NIST guy called Muli, and it gives like a high-level overview of microservice security and what you should be doing. And it basically says, well, you're always going to be trading security for resilience, and here's a sensible approach that you should take. 204A says, well, 204 gives you a lot of strategies, a lot of sort of high-level ideas for microservice security. A service mesh is a good way to hit them. It literally calls out service mesh as a class of tool. Because so many of these, especially in a cloud-native distributed system, everything is on the network. So many of these attacks are going to be network-based. a service mesh or a set of very complicated network policies, if that's how you want to do it, it's a good way to do that. So they do explicitly call it out, and they say, right, a mesh is a good way to do them. Like, here's how to pick a mesh that's going to give you everything you need, and here's how to deploy it securely. B is even more practical and talks about using that mesh configured in a way that gives you zero trust. I don't have time to go into zero trust. I did promise a couple of people I'd try to explain what that horrendous marketing term means. I'll be stood outside with a beer if you want me to define zero trust. I think I've got a fairly good way of doing it over a beer, because it takes a little while. We then got 204C, which is about DevSecOps. It basically says GitOps is good. We knew that, but this means the auditors know it. So crack on with Flux. It sounds silly, but and then D talks about getting CI right and basically says SBOMs are good. And Freddy from Testify, which again they are, but Freddy from Testify was in, well, if you use them correctly, they're a tool. But like Freddy from Testify was involved, like he's co-lead attack security in the CNCF, right? So they've got the cloud native people in. Freddy's a really great guy, so he was involved in trying to write this. So this is actually this is a pretty sensible document. So these are the ones, we're up to 2024 now. 207 says, 207 says more about zero trust. Get me a beer afterwards. That's the spoiler. 207A says, well, what is zero trust? Why are we doing it? What are we actually trying to achieve? So it talks about identity-based segregation. It talks about not trusting something just because of where it is in the network, trusting it because it has like a strong identity, and which shrinking that trust barrier down to every service. And I think I'm getting kicked off, so I will just say that there's 233, which is right down in the weeds, and is a comparison of data plane topologies in cloud-native systems. So if you're going to use one of these service meshes, there's ambient mode, there's sidecar mode, there's various ways of doing it. This tells you, especially if you're going to be doing the high level, that only one of these topologies is acceptable, like gives you the security guarantees you need, because ambient trades some security for some resource usage. So it says you need to use sidecar mode, basically. With that, I'm done.